All right. Well, good to see everybody today. Hope you had a good weekend. Second week of the 6 weeks, so we are moving along. Just a few things. I've got some more reminders up here on the board. The big one is going to be in 1 week. We have our first exam of the second 6 weeks, and it's going to cover all of the trig material, the first two lessons. The one that we're currently working on, where we introduced radians, and then the one you just picked up today on right triangle trigonometry. Okay, so reference angles, coterminal angles, bless you. I think I put a few word problems on there. Some of it's open-ended, some of it I made multiple choice, but you can use your what? You can use your notes, okay? So that's coming up 1 week on Monday. Tomorrow morning, unfortunately, there's not going to be any tutorials from 7:45 to 8:05. I'm going to be here, but what's happening next Wednesday? The PSAT, right? So I was lucky enough that my name was chosen. I get to administer the test next week. So I will be in a little training in the library, being shown how to do. I mean, I already know how to do it, but it's just by law. You have to be trained every time before you go ahead and do that. So that is what I will be doing in the morning. So I will be here for a little bit after school tomorrow if anybody wants to come in during that time. And then quiz on Wednesday. Normally, I go ahead and do these on Thursdays, but I'm going to go ahead and move the quiz to Wednesday. It's over this material right here, okay? But on Thursday, who do we normally have with us? What's her name? Yes, Miss Stern. Landry Stern. Landry's her first name. Yes, so Miss Stern. She is, for the first time, going to take over and teach you guys that day, and she's going to be talking to you about inverses and a couple of word problems. So I wanted to give her as much time as possible, so that's why I went ahead and moved it to Wednesday. Genevieve? Write her name on the board? Okay. Landry Stern. Here we go. All right, so she will be interacting with you guys for, I think, really the first time. Hadn't she done a focus activity with you? Yeah, I think so. Okay. But beyond that, she hasn't had a whole lot of opportunity, and she's only here with us the first semester, so we'll go ahead and get her in on that. All right, any questions, anything about what's going to be happening? No? Okay, well, help me out. How far did we get on Friday? I know that we introduced radians. We know that one revolution is 2 pi. We're on the very back page. Okay, good. Okay, so just a quick refresher, because radians are going to be so important to us. This is a measure that we can now associate with distance. Like we could say, we can measure the distance around a circle, maybe in feet, inches, whatever it is we're referring to. So a radian is going to be roughly 57.3 degrees. And how do we get it? Well, if you go ahead and take the length of your radius, whatever that length is, if I take that exact same length and I go ahead and apply it to the circle itself, okay, where it stops, when these two guys are the same, whatever angle is created, okay, from that, that's what we call a radian. Okay, that's 1 radian, so about 57.3 degrees. Now, what is 1 revolution in radians in terms of pi? Okay, 2 pi, there we go. So 1 full revolution all the way around is 2 pi. So we know by now 2 pi has got to be 360 degrees. They're going to be equivalent to each other. Let me go ahead and draw the other axes here. So if 2 pi is 1 full revolution all the way around, well then what's half of that? Pi, okay. And then half of that would be pi over 2. Now 3/4 of that, halfway between 1 pi and 2 pi, would be 1.5 pi, right? So we typically go ahead and say 3 pi over 2. And remember, one thing we were also working with was degrees. So we know 2 pi is equivalent to 360 degrees. Pi would be 180. What's pi over 2? 90. That's the degree measure of 1 quadrant. And what about 3 pi over 2? That's 270 degrees. There we go. And I think if I remember correctly, didn't we end on Friday kind of taking different radian measures and just Finding out what quadrant they were in? Okay, good. We'll do the same thing today to make sure you feel comfortable with that. Okay, good. So we did these guys down here. Okay, good. All right, well, looks like we are on the last page. Now, one of the main things we want to go ahead and do, oops, I might want to take that off right there, is go ahead and convert from degrees to radians or from radians to degrees. And it's a very simple conversion if we want to go ahead and do that. If I have degrees and I want radians, I'm just going to multiply that by pi over 180. Pi over 180, that's all you got to do. Okay. Now, if I want to go from radians to degrees, okay, I'm going to multiply by the reciprocal of that. I'm going to say 180 over pi. That is exactly right. Perfect. And now we got some examples here to go ahead and run through. So you'll know it's going to be in radians if it has pi. That's going to be like your big red flag. Degrees, we'll have that little open circle, the little notation we have for that. So let's say I have 7 pi over 6 radians, and I want to go ahead and get degrees. So I'm going to multiply this by 180 over pi. And you'll notice, what's the first thing to drop out? Yeah, the pi's. When you're going to convert a radian to degrees, pi is the first thing to go. There you go. Now, you can multiply 70 times 180 and then divide by 6. I think it's easier and faster if you simplify on the diagonals. Like, for example, 6 will divide into 180. How many times will it go in there? 30. So now 30 times 7 is going to be 210 degrees. Okay. Now, for any of these, if you want to go ahead and practice graphing the terminal side, just let me know. And I'll probably go ahead and choose one of these in just a second, just for some extra practice. But does anybody want to do A? It doesn't ask us to do it, but do we want to? Let's say I were giving you 7 pi over 6, and I just said, okay, I want you to show me that angle. Like, what quadrant would the terminal side end up in? Okay, the third. Now, we know it's 210 degrees, so if it's in degrees, it's going to be real easy to figure out the quadrant. But sometimes it's not always so easy if you're dealing with radians. So what I would always suggest is look at what portion of the circle that fraction represents. Like if it's an improper fraction with the numerator larger, I'd write it as a mixed number. How many times will 6 divide into 7? Once, with a remainder of 1, right? So 1 and 1/6 pi. Would everybody agree? Well, think about, the circle that we've been looking at. We start at 0 radians. We've got pi over 2, pi, 3 pi over 2, all the way back around to 2 pi, right? Well, the mixed number is telling you exactly how far to go. Like, for example, if I start here, remember, if you start on the positive x-axis, we call that what position? Standard position. So if I were to start there and I rotate it halfway, see, that's just 1 pi, right? See, that takes care of that. And now I just want to rotate a 1/6 more for pi. But pi is only half the circle. So 1/6 would probably be right about here. Okay. So that would be 7 pi over 6. Okay. Remember, as far as coterminal, reference angles, all of that remains the same. Okay, now again, we're doing, way more on this problem than it wanted me to. It just wanted to know the amount of degrees, okay? But let's say I did want to go ahead and know what the reference angle is. Remember, the reference angle is always created using 2 things: the closest x-axis and where the terminal side stops. So I want this angle right here. Well, what can I do to figure that out? Yeah, Lilybell says just subtract. Couldn't I take 7 pi over 6 and subtract pi? Just like if we were doing with degrees, you could subtract 180. Okay. Well, this is going to be 7 pi over 6 minus 6 pi over 6, because 6 over 6 is 1 pi, right? So the reference angle would just be 1 pi over 6. Okay. Do we want to practice? Yes, sir. Oh, we needed a common denominator. So I just multiplied both parts by 6 over 6. Okay. Does anybody want to go ahead and practice finding the coterminal angles? Or do you feel confident? Like if I were to give you one on, say, a quiz that's coming up, would you be able to do that? Okay, so let's do that. So coterminal, does anybody remember what those are? Okay, no. All right, so good. Coterminal angles, they're angles that have different measures, but they have the exact same terminal side. They stop in the exact same place. Okay. Now, typically, I'm just going to ask you for one positive and one negative. All right. So really, what was one revolution in radians again? It was 2 pi, right? So from the angle I have, 7 pi over 6, to find coterminal angles, I would simply add 2 pi to it and then subtract 2 pi from it. So let's add 2 pi. 7 pi over 6 plus 2 pi. So let me go ahead and put him over 1. Okay, so Brandon, what's my common denominator again? It's got to be 6. So this is going to be 7 pi over 6 plus 12 pi over 6. So 7 pi plus 12 pi. 19 pi over 6. So that would be a positive coterminal angle, the first one. Okay. Now, you remember how I said really focus on the fraction to help you out? Let's see what happens. What would 19/6 as a mixed number look like? How many times will 6 divided into 19? 3, right? So 19 pi over 6 would be 3 and 1/6 pi, right? That's exactly right, yeah. Okay. And let me go ahead and run through. So if I were to start here, okay, let me go all the way around. So here's 1 pi. Here's 2 pi. Here's 3 pi. So every half a revolution is 1 full pi, right? I've taken care of that. See, now all I got to do is go 1 additional 1/6 pi. So see, they stop at the exact same spot. That right there would be 19 pi over 6. I did this one in green. Okay. Now to find a negative coterminal angle, all I got to do is subtract 2 pi. Okay, so let's see. We know that we have a common denominator here, so I'm just going to change it. 7 pi over 6 minus 2 pi would be minus 12 pi over 6. But this time, what's a 7 pi minus 12 pi? Negative 5 pi over 6. So if I were to start here, let's go purple this time. So I'm in standard position, but because I have a negative angle, remember I'm going to go clockwise. So I'm going to rotate until I hit that. That would be negative 5 pi over 6. Yes? Well, think about it. 1 full revolution is 2 pi, right? So for 3, I only need 1.5 revolutions. Is that good? Yeah? Okay. Okay. Remember, for every half of a revolution, that's only pi. So that's why it's a really good idea to look at it in terms of a mixed number, because that tells you exactly how many times to rotate and then whatever portion you might have left. Okay. Do we want to look at another one of those? Not necessarily coterminal or reference angle, but just locating where the terminal side goes. Okay. So let me give you another one. And then we'll go back to what we had. Let's say we had, let's say 27 pi over 4. Okay. So let's think about this. Before we do anything, I want you guys to tell me what quadrant you believe it's going to fall in. Am I going to rotate clockwise or counterclockwise? Clockwise, because it's positive. Okay, so I'm just going to continue to rotate until it stops, right? Does anybody have an idea? Do we think it's 1, 2, 3, or 4? Okay, so I heard 1. Heard 4. Okay. Now remember, it starts off 0, and then you have pi. 1 full revolution is 2 pi. And then as you keep rotating, 3 pi, 4 pi, 5 pi, and so forth, right? Well, what would 27 fourths be as a mixed number? Okay. So it goes in there 6 times with a remainder of what? Okay. 3/4 pi. Okay. So let's see. I'm going to start here. So there's 1 pi, 2 pi, 3, 4, 5, 6. So that takes care of that. Now I just want to go 3/4 of pi. But remember, pi is only half of it. So I'm going to end up being in the second quadrant. So 3/4, I would be right here. Okay. So remember, it is perfectly fine to keep rotating in one direction or the other. I mean, you can rotate an infinite number of times. So some of these angles could potentially be pretty large. Okay. Depending on the sign. If it's positive, you're going to rotate counterclockwise. So in this direction, it has to be positive. If it's negative, then you're going to rotate the same way a clock does. Okay. All right, good, 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 good. All right, well, let's take a look at B, negative 2/3 pi. All I want to do, like I said, A, we went a lot further than we needed to. I was just kind of reviewing. Okay, so let's say all I want to do is take B and rewrite it as a degree measure. So I'm going to multiply by 180 over pi. What drops out? Pi. See? Easy as pie. Bless you. Okay. How many times will 3 divide into 180? 60. It's going to do itself once, into 180, 60. So now it looks like I have negative 2 times 60. Negative 120 degrees. So see, little bit of that one, I would actually rotate clockwise because it's negative. Okay. Let's try C. Negative 8 pi over 15. All right, well, I'm going to multiply by 180 over pi. Okay, pi's drop. In fact, what's a common factor between 15 and 180? Okay, ooh, 12 doesn't divide 15 evenly. Oh, I see what you're saying. You're saying the answer is 12 because 15 is the factor. You're right. 15 goes into itself once, but 180 divided by 15 is 12. And what's a negative 8 times 12? Negative 96. Okay. Any trouble going from a radian to a degree measure? Okay. Now I just want to go from a degree to a radian measure. So because these aren't fractions, I'm going to go ahead and take 135 and put him over 1. What am I going to multiply this guy by? Pi over 180. There we go. So my answer definitely will have pi. It's going to be in radians. But what's a common factor between 135 and 180? Now, you notice the first one, they're both divisible by 5, right? So you could simplify it and then continue to simplify it again. Can anybody tell me what the largest is? Oh, something bigger than 15. You're absolutely right. Angel says this is going to become 3 pi over 4 because the common factor is 45. So this one had a pretty large one. 135 divided by 45 will give me 3. And then 180 divided by 45 is where the 4 came from. Okay. Well, let's try negative 320. Okay. Well, negative 320. I have degrees, and I want radians. So pi over 180. And you notice if you have values that end in 0, that means they're divisible by 10. So you could just cross the zeros out. So now I have 32/18. And that makes it a lot easier. So Brandon's now telling me the common denominator is 2. So what would it be? Negative what? Okay, I heard negative 16 pi over, 9. Because both 32 and 18 are divisible by 9. There you go. Okay, and our last one here, F, negative 110 degrees. So that would be a negative 110 over 1 times pi over 180. Well, I'm going to do the same thing. I'm going to go ahead and mark those guys off. So do 11 and 18 have anything in common besides 1? Nope. So this one, we actually see what we needed. Negative 11 pi over 18. Okay, questions. How are we doing? Okay. All right, well, let's go ahead and do a few more. Looks like we're almost done with this lesson. And just avert your eyes real fast. La, 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 la. Forgot to erase that from the last class. La, la, la. Okay. All right, so how many radians is each angle of an equilateral triangle? Okay, so this is going back to geometry. What does equilateral mean? That means all three sides have the same length. Okay, so I'm looking at a triangle now that's equilateral. Well, if a triangle is equilateral, that means it's also Okay, what's the word for the angles? Equiangular. Do you guys remember? Okay. Now, nobody's gotten this one today. Let's see if you guys, anybody in here knows it. What do we call a figure that is both equilateral and equiangular? No, isosceles has at least two sides. Now, an equilateral, you can still call isosceles because, by definition, it has to have two sides congruent. An equilateral has three. So it still falls into that category. Do you guys remember the word apothegm or apothegm? Finding the area of figures? Depending on how your teacher said it. But we call those regular figures. If a figure is called regular, that means it's equilateral. All the side lengths are the same. And equiangular. All the angle measures are the same. Okay? Well, if I were to add all three angles of a triangle, I should get what? 180. So one of them's got to be 60. There you go. So all I want to do is how many radians is 60 degrees? Well, which one do I multiply this by? 180 over pi or pi over 180? Pi over 180. Okay, so let's see here. 60 over 180. So 3 times. There we go. So 60 1/80ths would be 1/3 pi, or pi over 3. And then we've got 2, 3, and 4. We're talking about a clock. I know what you're thinking. It's about time, right? Okay. I guess we ought to face the problem. All right, 2. The minute hand of a clock travels how many radians in 15 minutes? Okay, so let me go ahead and get a circle here to represent our clock. All right, so you know we have 12, 3, 6, 9. Okay, so let's say, you know, we're just looking for 15 minutes. So let's say that my minute hand starts at noon and it rotates until it gets to 3. Okay, well, how many degrees? That looks like 1/4 of a revolution. That's 90, right? So we're just wanting to know how many radians is that. So I want to take 90 degrees and change it to radians. What is it again? I keep forgetting. Pi over 180. And help me out. What is 90 over 180? Oh, not 2. Pi over 2, so 1/2 pi. There we go. Pi over 2. There we go. Yeah. Oh, now that's good. But remember, the positive and the negative just tells me the direction that it's rotating. So no matter what, you know, a clock is always going to go clockwise. So here we're just looking for the distance, the actual angle itself. So that's a good question. We don't need to worry about positive or negative, even though it is going clockwise. Okay. All right. That was a really good question. You know, I got to say, with the clock, I got to hand it to you. It's the hands of, you know. Okay, number 3. The minute hand of a clock travels how many radians in 10 minutes? Okay, well, if we knew the degrees, well, then all we got to do is convert it, right? So let's see. 1, 2. So let's focus on one quadrant. Now, these numbers are equally spaced, and you said one quadrant was 90 degrees. So each one of these is 30. That's right. So 30, 30, and 30, right? So we want to go 10 minutes, so I'm converting 60 degrees. And I believe we actually just did that a second ago. Pi over 180, that's pi over 3. Good. Now, what about in 5 minutes? What's my degree measure? Yeah, 30. Okay, we use that to figure out number 3. So 30 degrees over 1 times pi over 180. pi over 6. That is exactly right. Perfect. Pi over 6. Anybody having a hard time? Any questions? Yes, sir. Okay. Well, on number 3, see, we want to know 10 minutes, so we're still stuck to one quadrant, right? But with these numbers here, we know that the degree measure has to be the same because those numbers are evenly spaced, right? So if it's broken up by these 2, well, that gives me 3 sections. Now remember, what's the degree measure of one quadrant? I'm sorry? Oh, no, we're talking about degrees. 90, right, is in one quadrant. So if it's broken up into 3 equal sectors, then that's why we have the 30, 30, and 30. So like if you had a minute hand that started off, pointing up to noon, and it only rotated 10 minutes, well, then you're looking for the 30 plus 30. It should have rotated 60 degrees. Okay. Now, one of those sectors, the 5 minutes, would only have been 30. Okay. So think about it. Let's look at it like this. If every hour represents 30 degrees on the clock, well, then how far would the hand have rotated in, say, 20 minutes? "20 minutes being right here. Because wouldn't it have been 30, 30, 30, and another 30? Remember, 30 minutes for 30 degrees for every 5 minutes? Okay, so it'd be 120. How many degrees would the hand rotate in half an hour? That's half of the circle, so what would that be? 180. Okay. So see, we're still using the same measurements. We're not starting on what we believe the positive x-axis. We're just rotating within the clock. Okay. Good. Does that kind of help? Okay. All right, here are our last 2 examples. Let's see. What's the measure of theta in radians if x equals 45 degrees? Okay, so this measure right here is 45. Okay. Now, there's different ways that we could do this. If this is 45 degrees, but I know that all the way around is 360, well, how can I find that theta they want? Yeah, there you go. There's a lot of different ways. So what are we ending up with? 360? Oh, we're a little off. So we're looking for 360 minus the 45 degrees that we already have. 315. There we go. It is 315. Now, we're just wanting to know what that is in radians, right? So I'm going to do the same thing. I'm going to take 315 times pi over 180. And your calculator will go ahead and reduce this for you. If you just put 315 over 180 and push enter, it'll give you the reduced form. In fact, has anybody figured that out? 5.49? Okay, what would that be as a fraction? 7 pi over 4. That's exactly right. When you take 315 and put it over 180, okay, the common factor reduces. It's going to end up being 7/4. In fact, what is that common factor? Does anybody know? We saw it a moment ago on the previous example. It was the largest one we'd seen today. 45. 45 divides 315 7 times. It only divides 180 4 times. Okay, well, let's take a look at this last one, number 6. What's the measure of theta in radians? Okay. Well, does anybody tell me what's the measure of a straight angle? 180, right? So we know that's 180, but now we're comfortable saying 180 is also what? Pi. So why don't we do this? Let's take the 2 angles that we have, 5x and x. Let's add them up and set it equal to pi. So 5x plus x will give me 6x is equal to pi radians. Is everybody okay how I'm setting it up? Now, just solve for x. That would be pi over 6. But there's something I'm missing. It wants what? Well, we're in radians. Remember, it wants theta, right? What does theta represent? 5x. See, we have this one right here. There you go. We just go ahead and take my answer, 5 times pi over 6. So 5 pi over 6. Okay. There you go. See, we actually solved, we got x, but it wanted 5x because it wanted that measure theta. How we doing? Okay, sort of? Okay. It'll take a little bit of practice. You guys will be okay. Let me go ahead and give you your assignments. Okay. All right, there you go, man. Okay, so this is going to be due tomorrow. What I would encourage you to do is go ahead and get the DMS problems done. What does that mean? The degrees, minutes, seconds. Okay, because I did show you how to do it by hand. Well, it was up there by hand, but you'll just want to go ahead and use the calculator on that. So why don't we go ahead and look at a few of these together to make sure that you're comfortable with it. And I've got this right here. Okay. All right, I'll let you guys decide. 5 through 8, which one? Seven? Okay. 73 degrees, 20 minutes, 20 seconds. Okay. So here's what I'm going to do. Follow along in the calculator. Now, you're going to want to make sure that your calculator is in degrees. Okay. So on the home screen, I can just click 5. Okay, document settings. See, mine's already in degrees. So if yours is in radians, just click degrees, but then make sure to click make default. Okay. We want it in degrees because we're dealing with degrees. And now I'm just going to go to my scratch pad. Okay. So if you have DMS, degrees, minutes, seconds, all you want to do is just type that in. Number 7 starts out 73 degrees. So I'm going to type 73. Now I'm going to hit Control, and I'm going to hit this catalog button right here, this open book. And degrees is the top right symbol right here. Okay. Now I'm going to type in 20. And I'm going to go back to the same place. I'm going to hit Control, catalog, the open book, and the third icon in the second row, there's your little tick mark right there. And now I'm going to do it one more time for 20 seconds. Now, when I hit Control and the catalog here a third time, there is a double tick mark further down in your symbols, but that is actually used for a different operation. So we're just going to have to click the single twice, and that's okay. So I'll click it once, go back in one more time. There we go. As soon as I click enter, it gives me a fraction because I have my calculator set up. So just hit Control enter, and there you go. Now it says round your answers to the nearest what? Oh, it's at 2 decimal places. So that would be 73 point what? 34. So 73.34 degrees. Right beside the 9. This one right here? Oh, does that one come up too? Oh, I did not know that. Okay, that's great. Did everybody see where he got that from? No. Okay, let me show you. Let's say we want to put in number 5. Okay, so he's saying if you don't want to hit Control Catalog, push this button right here between 9 and the catalog. This button right here that has all the unusual symbols. In the second row, the second one right here. When you click it, it automatically, all you got to do is just fill in the blank. That is great. So you'll type in 62. What do we got? 4528. And then just push enter. Okay. Control enter. There you go. See, that makes it even faster. See, I did not know about that. That's excellent. You learn something new every day. Very cool. Very cool. Now, do we know how to go back if you're given the decimal and you want degrees, minutes, seconds? Do I need to do one of those? Yes? Okay. What do you think? 9, 10, 11, 12. 10. So it says 18.43 degrees. Okay, so what I'm going to do is just type in 18.43. Now, if you know of another way on the calculator about this, let me know. This is how I've always done it. I'm going to type in the decimal. Now I'm going to go to the catalog button. I'm not going to hit control. I'm just going to hit the catalog button. In the first tab, you want DMS. So if it's at the beginning of the alphabet for you, if you just hit D on your keyboard, it'll automatically jump you to the Ds, so you don't have to scroll all the way down there. But once you choose DMS, okay, I'm going to push enter, and it's automatically going to convert that for you. Yes. Okay. So if I were to type in 18.43, we're just going to go to the catalog, no control this time. Under the first tab, we want the DMS command, degrees, minutes, seconds. I'm sorry? Yeah, because if it starts at the A's, if you have to get to that tab, if you click D, it'll automatically jump you to the D's. Okay. Good, good, good. There you go. So those ought to go pretty quick. Numbers 1 through 4. Okay, those are just finding reference angles. Remember, those are created using the terminal side and the x-axis, the closest one. Then it looks like you have, I believe, some conversions on here. You're going from degrees to radians. Then you're going from radians to degrees. And then you just have a couple of problems very similar to what we did on the notes. Okay, Genevieve. Yes, if it doesn't have seconds, you could leave it as is, or you could just type 0 and then 2 tick marks. 0 seconds, that's equivalent. Okay. It's very possible that could happen. All right. Yes. 26. Okay, let's take a look at it. It says problems 25 and 26, find the measure of theta. Now, theta has me going to this guy right here. So we want him in both degrees and radians. Okay, well, what's half a revolution? Just to go from here to here, that's what? So we already have 180, right? Now, it looks like we're in the third quadrant. And remember, we just talked about this with the time problem. One quadrant is 90 degrees, right? But it looks like I've got 3 areas that are of equal measure because of the little arc with the tick mark in them. So what would each of those individually be? 30. So what's the degree measure rotating around until I stop there? What am I going to do with those 2 numbers? Okay, so I know that halfway gave me 180. I know that each of these 3 little areas right here is 30 degrees. So what's the measure of my angle if I rotate all the way around and stop there? Now, see here, do I need to subtract? Because I'm wanting to go further, I want to add, right? So 180 plus 30 would be 210. But now it wants radians and degrees, right? So while this is one of my answers, let's take the 210 and go ahead and figure out what the degree measure is. I'll be right with you. Okay. But now they're both ending in 0, so I can go ahead and just take those out. What's 21/18? 7/6. There you go. In fact, we saw that on the assignment. So 7 pi over 6 radians. There you go. And
So do it that way. If we added movement the other way, the arrow on top.
oh, so you're saying like if we were to stop like right here? Yes, then you would subtract because you're smaller than 180. So it depends on where you stop. If you go further than, it also depends on what you're looking for. If you just want the reference angle, you would have to subtract them. If you're wanting the full measure, like we were here, then you would add them. Okay, so it all really depends on what you're asked to find. Okay, but this kind of material right here, this is exactly what your quiz is going to be over.
Quiz is what, Wednesday?
Wednesday, yes ma'am. So tomorrow we'll turn in the homework, and then we'll go ahead and take this quiz on Wednesday. Good, we still got a couple minutes left, so let me go ahead and